GCE Advanced Level Chemistry Practical Series, experiment number 7. Experimental determination of the enthalpy of acid-base neutralization. In this practical, we aim to learn how to measure the temperature changes of a chemical reaction that is taking place, and later on we are going to learn how to determine the enthalpy of an acid-base neutralization reaction. Now, let's move on to identifying the equipment and the reagents we will be using for this experiment. In this practical, the basic idea is to react an acid with a base and measure the highest temperature that particular reaction mixture reaches. So, for this purpose, we will be using a variety of acids and bases. Let's identify the bases we will be using for this practical. We will be using sodium hydroxide, potassium hydroxide, ammonium hydroxide. These are the 3 bases we will be using, and you can see the concentration of each of these solutions. Each of these solutions has a concentration of 2 moles per decimeters cube. And we will be using 3 different types of acids as well. We will be using HCl acid, we will be using nitric acid, and we will be using ethanoic acid. All of the acids also has the same concentration, which is 2 moles per decimeters cube. Apart from the acids, we will be using a little bit of distilled water to wash the utensils we are using. We will be using measuring cylinders to measure the acid and the base accurately. We will be using a thermometer to measure the temperature accurately. And when the reaction is taking place, we need to make sure that all of the heat that is flowing into the system or out of the system is contained within the system. So therefore, we are using a heat insulated setup. What you see here is a plastic beaker, and inside the plastic beaker we have another plastic beaker with some insulation inside of the beaker, so that whatever the heat that is released or absorbed remains inside the system, and we do not release any heat towards the surrounding, or we do not absorb heat from the surrounding when this reaction is taking place, when we are conducting the experiment inside this setup. Apart from that, we will be using a thermometer that is directly included into this setup. We can see we have a lid here, and there's an opening. Inside this lid, we can see here, through these openings we will be inserting our thermometer, and we have set up our thermometer on a retort stand. These are the equipment and our reagents we will be using for this experiment. Now, let's move on to actually conducting our experiment. In the first part of our experiment, we are going to see a reaction between HCl and sodium hydroxide. HCl is a strong acid and sodium hydroxide is a strong base. Now we are going to see the reaction between a strong acid and a strong base and measure the temperature increase when this reaction is happening. Normally, an acid-base reaction is an exothermic reaction. Exothermic reaction means as the reaction proceeds, energy will be given out of the reaction. Energy will be released from the reaction. This energy will be taken up by the water in the solution, and the temperature of the water will increase. When we are conducting this experiment, we are going to measure the temperature increase of this reaction. Due to the fact that we know the volume of the solutions we are using, we know the overall volume of the reaction mixture. Thereby, we know the overall volume of water that we are using here. And with the use of the temperature increase we can calculate the amount of heat that is released from the system. And as we carry this experiment out, we are conducting this experiment at atmospheric pressure conditions. So we assume that we subject this reaction mixture also into a constant atmospheric pressure condition. Now, let's move on to adding our HCl into this plastic container, and afterwards let's take the temperature readings of HCl and the sodium hydroxide we're adding to this reaction mixture. We have our measuring cylinder here, and let's take our HCl solution and let's add 50 milliliters of HCl into this beaker. As always, when measuring volumes, make sure to take the measuring cylinder to your eye level. Otherwise, you will not be measuring the right amount of solution. So we have measured the right volume here, which is 50 milliliters of HCl. Now, we are going to be adding this 50 milliliters of HCl into this plastic beaker. Afterwards, we can lower this thermometer into our HCl solution. Now, let's take a look at the temperature reading of our HCl solution. The temperature reading of our HCl solution is 27 degrees Celsius. Let's move on to measuring the temperature reading of our sodium hydroxide solution. We have our sodium hydroxide solution here. And now we'll use a different thermometer and measure the temperature of the sodium hydroxide solution. The temperature of the sodium hydroxide solution is also at 27 degrees Celsius. Now, let's move on to the next step of our reaction. In our next step, we are going to measure 50 milliliters of sodium hydroxide solution. After measuring 50 milliliters of sodium hydroxide solution, we have to add the sodium hydroxide into this reaction mixture, and as soon as you do that, you have to measure the temperature increase of this reaction mixture. At the same time, you have to make sure that you close the lid of this container so that you won't have any heat loss through the top part of this beaker. We'll lift this thermometer out of the way, and we have to work fast at this point. We have to add our sodium hydroxide solution into this container, and as soon as we do that, we have to make sure that we close the lid and insert the thermometer into the reaction mixture to get a temperature reading. We'll place the lid like so, and we'll bring this thermometer down to the right level. As soon as we add the sodium hydroxide, all that is left to do is closing the lid. Now, let's add our sodium hydroxide solution. And we'll close this properly. Using a glass rod, we can stir the solution as well. Now you can see the temperature rising as the reaction proceeds. And we have to observe the highest temperature it reaches when the reaction starts to take place. Now the temperature is at 40 degrees Celsius. We have to observe the highest temperature that it reaches over the course of 1.5 to 2 minutes. Now, we observed when we initially mixed the hydrochloric acid with the sodium hydroxide solution, there was an increase in temperature all the way up to 40 degrees Celsius. And we observed if the temperature was increasing further than 40 degrees of Celsius. However, now it has started to come down. So the highest recorded temperature when this reaction was taking place was 40 degrees Celsius. After recording that temperature, we can move on to our next reaction. In the second part of our practical, we are going to be looking into a reaction between potassium hydroxide and nitric acid. Now, let's first measure 50 milliliters of nitric acid and transfer into our plastic container here. We have our nitric acid over here. We are going to take measuring cylinder and measure 50 milliliters of nitric acid. After measuring 50 milliliters of nitric acid, we are going to transfer this into this plastic container we have here, which is insulated. And now we are going to measure the temperature of our nitric acid. At the same time, we can measure the temperature of the base we are using. We are going to be using potassium hydroxide as our base. Now, let's take the temperature of potassium hydroxide as well. As you can see, the temperature of the acid is at 26 degrees Celsius and the temperature of the base is at 25 degrees Celsius. After recording the temperatures, we can now moving on to measuring 50 milliliters of our base. We have 50 milliliters of the potassium hydroxide base measured here. Now, we are going to add this 50 milliliters of potassium hydroxide to our nitric acid solution we have here. As soon as we add our potassium hydroxide solution into our nitric acid solution, we are going to record the highest temperature that this reaction mixture is going to reach. We have our potassium hydroxide. Now we are adding it to our nitric acid solution and we are going to measure the highest temperature that this reaction mixture is going to reach to. We can mix the solution a little bit as well. And we are going to observe the highest temperature this reaction mixture is going to reach to now. In this second part of our experiment, after reacting potassium hydroxide with nitric acid, we allow the reaction to proceed for about 2 minutes, and we recorded the highest temperature that it has reached. According to our observations, the highest temperature that it has reached to is 38 degrees Celsius. Initial temperature of the acid was 26 degrees Celsius. Initial temperature of the base was 25 degrees Celsius. And the final highest temperature of the reaction mixture was 38 degrees Celsius. Now, after recording these temperature measurements, we can move on to our third part of this experiment. In the third part of our experiment, we are going to see an acid-base reaction between a strong base and a weak acid. We are going to use sodium hydroxide as our strong base, and we will be using ethanoic acid, or commonly known as acetic acid, as our weak acid. Both will have a concentration of 2 moles per decimeters cube concentration, and we are going to first measure 50 milliliters of ethanoic acid and transfer it into this beaker, and we are going to measure the temperature of the acid. Like before, we will be using a measuring cylinder, and we have our ethanoic acid here. We will take our ethanoic acid, and now we are going to measure 50 milliliters of this acid. Now we have measured 50 milliliters of that acid. Now let's transfer it into our beaker and measure the temperature. Now let's measure the temperature of the base as well. We will be using sodium hydroxide as our base. Let's take the base here, and we are going to use a different thermometer which has been washed since the last time we used it, and we are going to measure the temperature of the sodium hydroxide as well. You can see a side-by-side comparison of the two temperatures now. You can see on your left hand side you have your weak acid, which is ethanoic acid. You can see the temperature of the ethanoic acid. And on your right hand side you have your base, which is sodium hydroxide, which is a strong base. We observe the temperature of ethanoic acid as well as the sodium hydroxide we are using for this reaction. Both were at 26 degrees Celsius. Now we are going to measure 50 milliliters of sodium hydroxide using a measuring cylinder. And after measuring 50 milliliters of sodium hydroxide, we have to be prepared to close the lid of this setup and take a look at the highest temperature that the reaction mixture is reaching to. After getting ready to close the lid, we are going to be adding our sodium hydroxide to this acetic acid we have in the beaker. As soon as it is added, we are going to close the lid like so and take the temperature reading. We can mix the reaction mixture as well. And we are going to measure the highest temperature that this reaction mixture is going to reach. After allowing the reaction to run for a while, we observe the highest temperature that the system reached to. The highest temperature that the system reached to was 38 degrees Celsius. Now, we have to note down the initial temperatures of the solution. Both of the solutions were at 26 degrees Celsius. Now, after the reaction has gone to completion, the highest temperature that we recorded was 38 degrees Celsius. Now, let's move on to our final part of this practical. In our final part of this practical, we are going to observe a reaction between a strong acid and a weak base. For the strong acid, we have chosen hydrochloric acid, and for the weak base, we have chosen ammonium hydroxide. Now, let's measure 50 milliliters of hydrochloric acid and measure the temperature of our hydrochloric acid. We'll take our measuring cylinder here, and we have our hydrochloric acid, and let's measure 50 milliliters of hydrochloric acid. We have taken 50 milliliters of hydrochloric acid, and we are going to add this hydrochloric acid into our plastic container here. And let's measure the temperature. While we measure the temperature of our hydrochloric acid, we can take ammonium hydroxide that we have here and measure the temperature of our ammonium hydroxide solution as well, so that we can compare the temperatures side by side. You can see in our HCl solution, the temperature reading is 26 degrees Celsius. And in our ammonium hydroxide solution, the temperature is 24 degrees Celsius. Ammonium hydroxide solution is somewhat cooler than the HCl solution we have here. After noting down these temperature readings, we can move on to measuring 50 milliliters of ammonium hydroxide and adding it to our hydrochloric acid. Now, Let's take a measuring cylinder and measure 50 milliliters of ammonium hydroxide. We have measured here 50 milliliters of ammonium hydroxide. Now we are going to add this ammonium hydroxide into the HCl solution we have here in the plastic container, and we are going to close the lid and measure the temperature reading we obtain as soon as we mix the two reactants together. So let's add ammonium hydroxide into this container. And now you can see as the reaction proceeds, the temperature starts to increase. Now we can see towards the end of this reaction, we observed the temperature going up and coming down, and the highest temperature that this reaction mixture reached out to was 37.5. The initial temperature of the acid was 26 degrees Celsius. The initial temperature of the base was 24 degrees Celsius, and the highest temperature that the reaction mixture reached was 37.5 degrees Celsius. Let's move on to an additional reaction that we are going to show you in this experiment. In this additional part of our practical, we are going to take a look at the reaction between a weak acid and a weak base. For the weak acid, we have selected ethanoic acid, and for the weak base, we have selected ammonium hydroxide. Just like in the previous examples, we are going to measure 50 milliliters of our weak acid, which is acetic acid. So we have measured 50 milliliters of ethanoic acid, and now after measuring 50 milliliters of ethanoic acid, we are going to transfer it into our plastic beaker here, and we'll get the temperature of this ethanoic acid. We have our ammonium hydroxide solution here. We are going to measure the temperature of the ammonium hydroxide solution right next to our ethanoic acid solution. Now you can see the two temperatures here. Left hand side, we have the temperature of our acetic acid solution, which is 26 degrees Celsius, and on the right hand side, we have the temperature of the ammonium hydroxide solution, which is 22 degrees Celsius. Now let's move on to measuring 50 milliliters of our ammonium hydroxide solution. We have now measured 50 milliliters of ammonium hydroxide, and we are going to add that to this plastic beaker here, which is insulated, and we are going to measure the temperature change that takes place when we add our ammonium hydroxide solution. And let's measure the highest temperature that this reaction mixture reaches to. Now, we have allowed the reaction to take place for over 2 minutes, and we observe the highest temperature that it reaches to is 34 degrees Celsius. The acid had an initial temperature of 26 degrees Celsius. The base had an initial temperature of 22 degrees Celsius. And after mixing it, the final reaction mixture reaches a highest temperature of 34 degrees Celsius. After taking down these temperature readings, we can now move on to the enthalpy calculations and the important theory parts revolving around this experiment. Now, let's move on to the next session where we discuss the calculations.